Jamb 2026 candidates, we are treating Shah's law. And do not forget to message me if you need any assistance. Is it last minute preparation? Is it access to short and concise lesson material, lesson notes, which contains Jamb must repeat questions too for your practice? Send a DM, okay? Send a DM. Let's go. Under Shah's law, Jamb must repeat question 4. The question reads, a given amount of gas occupies 600.0 milliliters at 20 degrees Celsius. What is the volume at 60 degrees Celsius? Constant pressure. So pressure remains constant. So when you see this constant pressure, just know you are talking about Shah's law. You see constant temperature, you know you are talking about Boyle's law. Okay, remember, Shah's law is a direct variation of volume and temperature. That's volume, direct variation, temperature. Okay, you're now going to have equal to V1 over T1 equal to V2 over T2. Okay, so this is the formula. All right, it's a direct variation. Okay, so at constant pressure, okay, as constant pressure, that's P is constant. First of all, let's write what we were told to find. Okay, a given amount of gas occupies, so we have V1 now. This is the volume, V1, 600 milliliter. Okay, let's write it down. In fact, giving V1 equal to 600 milliliter. Okay, then at 20 degrees Celsius, that's they give us temperature. This one is T1, first temperature, equal to 20 degrees Celsius. Since it's Shah's law, I always say that it's only Boyle's law that you don't need conversion of temperature to Kelvin. The temperature should be in Kelvin. Okay, it's only Boyle's law that is exempted because Boyle's law is not, it does not vary with temperature. It's just constant temperature. But for Shah's law, ID gas, general gas law, ensure you convert your temperature to Kelvin. Okay, so the next thing we are putting here is we can quickly convert to Kelvin. If we convert to Kelvin, we are going to get 20 plus 273. That will give us what? 293 Kelvin. Okay, so this one is our T1. Okay, then what is the volume at 60 degrees Celsius? So they give us T2 now. This is the second temperature. T2 is equal to 60 degrees Celsius. If we convert now again, we are going to get 60 plus 273 equal to 60 plus 273. We are going to get 333 Kelvin. All right. Hope that's right. Hope that was well converted. All right. So they said at constant pressure. So this is what we are looking for. They said we should find what is the volume that we are looking for. Final volume. This is first volume. We are looking for second volume. V2 is equal to question mark. Okay. So since it's V2, we are looking. No need to do any subject or formula here. Just substitute and get your answer. If you are solving all these gas laws, substitute and get your answer. What is our V1? Our V1 is 600 over what's our T1? T1 is 293 equal to. What's our V2? Our V2 is not in question mark. Now we define, put your V2 there over. What is our T2? Our T2 is what? 333, sorry. 333. So here now, because you have number here, and here you have only one alphabet that is not number. What you have to do here is to do what? To cross multiply. Normal mathematics rule, okay? This times this, okay? You are now going to be left with something like this. 333 times 600 over. This one will not times this one. This one will not times this one, okay? 293 times V2. If you times it by V2, it give us 293 V2. So this times this will give us, let's come down. This times this will give us, that should give us about 199. That's what calculator says, 800, okay? Over, what do we have down there? 293 V2. Okay, so you bring your V2 down, that's V2. You divide. When you divide this one by this one, you are going to get, calculator says 681.911. Okay, so this is the final volume. Initial volume was in what? Initial volume was in milliliter, so final volume will also be in milliliter. Among the options, pick the correct option or the closest option and drop it in the comment section. Let's treat ID gas next. Jamb must repeat question 3 under the topic ID gas. Okay, the question read, a given amount of gas occupies 10.0 decimeter cube at 4 atmosphere and 273 degrees Celsius. The number of moles of the gas present is what? The number of moles. So what we are looking for here is what? The number of mole given. We are looking for what? N. Okay, is the number of mole, question mark. That's what we are looking for. So let's look at the option. Options are represented in what? Mole. All the options are mole. Now the unit way. So our answer must be in mole. So what we go do now? Let's write out the formula for the ID gas. Okay, let me ask you now, how do we know that we are supposed to use ID gas to solve this? When you see this molar volume of gas at STP, you also come here now and you see mole. Okay, mole. They are asking us to calculate mole, number of mole. Just know we are talking about ID gas. Okay, let me show you. We already treated this. I treated this in my lessons. Okay, if you have taken my lessons, this should be like my mind to you. Okay, the formula of ID gas is PV is equal to nRT. Okay, this one is capital letter T, but okay, let me put it capital letter T because it's temperature. It's not time. Okay, capital letter T. Okay, where P is equal to pressure. Okay, in atmosphere, it must be in atmosphere. If it's not in atmosphere, convert it to atmosphere. Okay, V, when you are using ideal gas to solve, if it's not in atmosphere, make sure you convert it to atmosphere before you solve. Okay, where V is equal to volume, and the volume should be in what? Cubic decimeter, or it should be in liter. Okay, where the next thing, the N, this one is number of mole of the gas. Then the next thing there is R. This R is what? The gas constant. R equal to gas constant. Okay, this one is the gas constant, which is usually equal to 0.082 liter or atmosphere per mole Kelvin, or it can be in liter or it can be in atmosphere, okay, per mole Kelvin. Okay, just like this. Okay, or this can serve as molar volume at standard temperature and pressure, where T is equal to what? Temperature. Okay, so this is the ideal gas. Make sure you learn this and know what each of them, what they represent. All right, so let's now write out all we were given to solve, and see if it matches this perfectly, to see if we can use this formula or if we have to modify the formula. Okay, so we were given, we've written N, that's what we are looking for, N, and we were given the first volume. Okay, that's the volume, 10. Okay, 10 cubic decimeter. V is equal to 10 cubic decimeter. Okay, we are given temperature equal to 273, and we were given what again? What were we given? We were given molar volume of gas at STP. Okay, molar volume of gas at STP. This one. Okay, we're giving molar volume. Okay, molar volume of gas, MV. Let's just put it MV equal to 22.4 decimeter. Okay, I'm left to solve with this. But here in the ideal gas, we have R, and R represents what? It's a gas constant, which is this. So we are not going to use this. Since we are using ideal gas and it has a gas constant, we are not using this. Okay, so because we are looking for, what we are finding is the number of mole. That's what we are looking for. So we are going to use this one. R is equal to this, 0.082. Okay, 0.082. So they also gave us pressure, and pressure is 4 atmosphere. Look at it, we didn't put it. Pressure equal to 4 atmosphere. Okay, so that's that for that. Let me separate this. Okay, so let's see what we can do. Let's find the solution to this problem. Okay, so the ideal gas equation, this is the ideal gas equation. Since we are looking for the number of mole N, we are going to make N the subject of the formula. N will now be equal to what? How do we make it the subject of the formula? N, if you bring N to this side, you are now going to have a fraction here. Okay, so you are having a fraction PV. This PV that is coming to this side will go up, the RT will be down. So we have PV over RT. All right, so we are going to use this towards solve. So substituting into it, we are now going to have N is equal to what? What is P? P is 4 atmosphere. Remember, let it be in atmosphere. Volume must be in decimeter cube or liter. If you compare everything, you see that everything tally well. It tally. Okay, so times V. What is our V? Our V is 10. Okay, over what's our R? R 0.082 times. Okay, what do we have there again? We have T, temperature. What's our temperature? 273. 273. That's our temperature. All right, so we are going to simplify now. N is equal to, when you solve this down here, this times this is going to give us, okay, let's do the up first. 4 times 10 will give us 40 over this times this will give us we didn't convert our temperature. We didn't convert our temperature. This temperature, we are supposed to add 273 to it. Please don't forget to, it's only Boyle's law that you don't add 273 to the temperature. That's to convert it to Kelvin. Okay, always add 273 to the temperature. If you don't add 273, you don't get the answer. So we all add them for inside here. 273. Okay. Okay. Always convert to Kelvin. Add 273. It's always in Kelvin. Okay. So if you add 273 plus 273, or 273 times 2 will give us 5 something. Should be 546. Okay. 546 times, what do we have here? This 0.00 something. Okay. 0.082. Okay. Times 546. All right. So when you times this by this, it's going to give us N is equal to 40 over 4.772 equal to, if you divide this by this, it will give you 0.89. 0.89. And since we are looking for number of mole, what should it be? Mole. Among the options, pick the correct option or the closest option. Drop it in the comment section. I will see you in the next class.